So the test on chapter 11, chapter 12, that's what we're coming up here on. Section-wise, we've got a couple anyway, 11:1, 2, 3, and we skip to 5. From 11 and 12, we started 12:2 and went through 12.5. All right, so as you remember, those chapters, chapter 11 was, we talked about probability. And on section 1, all right, so section 1, you know, it's really just identifying. So if you want the probability of something, call it E for event. You just take the number of times that could occur, like for heads, or whatever. The number of successes, divide that by the total number of outcomes there are. Pretty simple way of doing it, but that's probability. So probability is a fraction. The decimal, sometimes we use a decimal, but that's what probability is. Now, also there, what's kind of tricky on that is, what about if I ask about odds? Well, the odds are different. Just to give us an example here. Yeah, so if I flip a coin 2 times, or flip 2 coins, let's say. Number 1, what is the probability both are heads? Well, probably done it before, but just want to make a point here. Probability both are heads, so 2 coins, we got heads, 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 tails, tails, heads, tails, tails. 4 possible outcomes. So the probability both are heads, 1 out of 4. Right? Now, on the other hand, when we come to odds, we've got 2 here, odds in favor, odds against. And the only difference between those is the ordering. The odds in favor, you know, when we did the odds, we called them favorable and unfavorable. For the odds in favor, the second number is not the total, it's the number of unfavorable, the ones that aren't favorable. So over here on our example, so what are the odds in favor of both being heads? Well, the odds in favor, that's favorable to unfavorable, and you know, you can use the word to or colon if you prefer, but the number of favorable, so the favorable ones are the 2 heads, so there's 1 of those, but then the second number is not 4, it's the unfavorable, which are the other ones. So in this case it's 3, yeah, 1 to 3 would be the odds in favor. Okay. So note the difference there, slightly different numbers for probability and odds. Now, the odds against, what's the difference there? You just flip them, right? It's unfavorable first, and then favorable. And so the odds against here would be 3 to 1. Okay, so please note that. Odds, slightly different from probability. All right, So that was section 11.1. 11.2 and 11.3. Okay, that was that got a couple more formulas, equations, I guess, to remember. 11.2 was about or probabilities. So the probability of A or B, there was a formula. Remember, it was probability of A, or that word typically means addition. So we add the probability of B with a slight catch. Remember, the rest of it was you got to subtract the probability that it's both A and B at the same time. So that's the formula for or. Then 11.3 was the and. So probability of A and B. Like when we were drawing the two cards, we used this one. Several other examples, but and if we have to use a formula there, it's and means multiply. So it's probability of A times the probability of B. The catch is, though, B, for the B, we use that conditional probability, B given A, like when we were drawing the two cards, the second card was given that the first card happened. So like if we were drawing without replacements, you know, take that into consideration. I'm not going to go all the way through it again, but yeah, so we use that conditional probability. Now, if A and B are independent, then you don't have to worry about the conditional probability. The probability of A and B is just probability of A times the probability of B. So, yeah, you don't have to worry about the conditional, but again, key thing, and means multiply, so if you use that word, then you want to just multiply. Get the highlights here. 11.5, that was the expected values. Which that also brings up another term here. So on the expected values, what we usually try to do is put together a probability distribution. Where that just means X, P of X table is what we meant by that. So you put that together where X is, you know, whatever it is, like the winnings or what insurance, what was their income or expected income. Anyway, something like that. Well, anyway, if we get the probability distribution, then the expected value of X, then is just all the X times P of X's. Yeah, so, you know, X is 1, and P of X here is 0.25, X is 2, 0.1, and 3, so forth and so on. Yeah, we just multiply each X times P of X, add those together, and that's your expected value. It's called the expected value. All right, so that's chapter 11. Any questions about anything there? Summary of it, anyway.
So you divide it by what?
No, it's just the,
It's just that?
on this, yeah,
Oh, okay.
yeah. When we get to 12.2, that's where we have the divide. Yeah, I put it up there. Divide. All right, so chapter 12 was, we talked about statistics in chapter 12. Just kind of an introduction to it. Mean, median, mode, so certainly be aware of those. Means the average, median's the middle, mode's the most frequent. And the more complicated of those is from the frequency distribution. Getting those from the frequency distribution, and so yeah, the mean is, that's where you have your values and your frequencies. For the mean, yeah, you multiply the X bar is what we call the mean. That's where you would multiply the values times the frequencies and then add those together. So the sum of the value times frequencies. And then you divide that by the total of the frequencies. That's how you get your average. So that might be what you're thinking there on the other one. But and then you know your median, you find your middle value. The mode, of course, is the most frequent one. But so be sure to look over that if you have a question about that. Oh, and then that's 12.2. Also on 12.2, grade point average. I do have a grade point average problem on this test usually, so be sure you calculate the grade point average. Even classes and their grades earned. See 12.3. So these were measures of position, measures of central tendency. Then we went to measures of dispersion, which was the range and standard deviation. Of course, standard deviation is the more complicated of those two, obviously. So yeah, remember on the standard deviations what, whatever, just making up some values here. So the standard deviations, what you would do is you take the deviations, which is just the value minus mean. I'll just make up so let's say the standard deviation here is 9. I mean the mean is 9. So to do the standard deviation, you just subtract value minus mean on each one of these. So if our mean is 9, so we got -5, -4, -1, +1, 7, and then whatever the rest are. Just going through a real quick example here, starting anyway. All right, then you square those. Square deviation, so -5. Well, when you square them, they're all positive, so that's +25, +16, +1, +1, 49, etc., etc. So to get the standard deviation, which is S, remember you take the sum of all the squared deviations, then divide by the number there are minus 1, n minus 1 we called it, and then square root that. So you take the sum of all these, which I didn't do them all, this particular example, but you just add all those up, put them here, divide by the number there are minus 1, and then square root that. That'll get your standard deviation. It's called standard deviation. Now, the other aspect to that, what does standard deviation measure? It's dispersion, right? So the more dispersed the data are, the higher the standard deviation. So if I ask you which of the values were more dispersed, which distribution had the more dispersed values, the one with the higher standard deviation. The mean gives you the average, so if I want the higher average, you go for the higher mean. But if I want the higher dispersion, you go with the higher standard deviation. And that was one thing we asked about there. 12, moving on here, 12.4 was measures of position. Okay, we talked about 2 there. Position, we talked about the percentiles, make sure you know those mean, and then the z-score. Z equals value minus mean divided by standard deviation is the z-score. But what that kind of does is that also, the way we used it is that kind of standardizes position between different distributions. So if you've got a different distribution with a different mean, different standard deviation, this kind of standardizes it, gives you the position relative to other values in it. And so you can compare scores from one distribution to another distribution. So that's kind of how we used it. But
And you said you would provide like the chart?
yeah, now the chart comes in 12.5. This was just calculating the z-score. But yeah, at 12.5 we talked about the normal distribution. Bell-shaped curve. And so yeah, one type of problem on the normal distribution, we use the table, which the table will be provided, yes. It will be on the test. You'll have to memorize that or bring a copy of it in. Be doing that. The other, though, we'll have also a couple of questions on using the empirical rule, which that requires you to remember a couple of percentages, at least anyway. The 68%, 95%, and 99.7%, which that's within one standard deviation. The 68% within 2 standard deviations is 95%, and then within 3 is 99.7. And of course, sometimes you have to half those, and it just depends on the picture. But yeah, be able to draw normal distributions and then work with them using these 2 methods, which we did last time. I think that's summary anyway. That's what we did in these 2 chapters.